We're going to talk about medians, not medium, median, altitude, and perpendicular bisector. Okay, a median is a segment that goes from a vertex to a midpoint. Every triangle has three, because they have three vertices and three midpoints, right? So if this is our midpoint, that would mean these two sides are the same, and the median would go from here to here. Okay, and since every triangle has three, we have another, if that's a midpoint, we have another median that goes from here to here. And then if this is a midpoint, we have one that goes from here to there. Okay, now if drawn properly, they'll meet at a point in the middle. So let me kind of fix my lines a little bit. And we're going to talk about the point where they meet later. So just pretend that these are all straight lines and they intersect at a point, which, like I said, we'll talk about that point later on. But
Would they all intersect?
yeah, all three medians will always intersect at the same point in a triangle. But right now, all you need to know is that a median goes from the vertex to the midpoint. Okay. Now, an altitude goes from a vertex and then goes perpendicular to the opposite side. Again, every triangle has three. But they might be in or out of triangle. So, for example, this altitude going from this vertex to the opposite side would be inside the triangle. That's one altitude. But these altitudes, because of the nature of the triangle, sorry, I did that wrong. We want this side. What we would do is we would take and extend out the sides like this. And if I'm coming perpendicular to this side over here, you can see it's going to be outside of the triangle. That's another altitude. And then for this altitude, if I extend out this side, this altitude would also be outside of the triangle. So depending on the individual triangle, if it's an acute triangle, they'll all be inside. But if you have an obtuse triangle, you get outside. It can also be on the side. That's if it's a right triangle. And here's why. If I give you a right triangle, that's a perpendicular right there. So this vertex already has a perpendicular to the opposite side. So that side of the triangle is also the altitude. And here, this side of the triangle is also the altitude. Okay, does that make sense? Think about when you've done area of triangles and it's 1/2 base times height. The altitude is the height of the triangle based on the side that you're looking at. And height is always perpendicular to the ground. So if this green line right here is the ground, this is the height of that triangle. And off all the corners, yeah. And then you're trying to go perpendicular to the other side. So in this case, we could do that and stay inside the triangle, but over here, I can't, to be perpendicular to this side, I have to come outside of the triangle. Does that make sense? So with an altitude, you can be inside the triangle, outside of the triangle, or the very edge of the triangle. With a median, you're always inside because you're going to the midpoint of the other side. So you'll stay in the triangle. Okay. Now, an altitude and a median can be the same line. If, for example, you have an isosceles triangle, let me draw that up here. So let's just say I have this pretty isosceles triangle up here. And here's my midpoint, and here's my median. It's also an altitude. So they're not exclusive of each other. That can be both. You can be a median and an altitude at the same time, but only in an equilateral or isosceles triangle. Any normal scalene triangle is going to be, they're not going to be the same. Okay, perpendicular bisector is a line, segment, ray, or plane that is perpendicular to a segment and bisects it. We've talked about this before. Perpendicular bisectors. And then we have equidistance, which is the same distance. So if I have a line segment and I have some midpoint, helps if I'm on the right thing, midpoint, then the perpendicular bisector will come in and bisect. Okay. And then equidistance means the same distance. So again, if I have, for example, a line segment, or I could have an angle, we have the same distance here as we have here. So maybe that's 10 and that's 10, same distance. Or I can put some point in the middle of this angle and I can have the same distance here as here, maybe 30 degrees and 30 degrees, something like that. So equally distant. Okay. So what we have is, based on that, if we have a point that is equidistant from the sides of the triangle, if an angle, which we kind of just drew, I have an angle, I have a point. If this distance is the same as this distance, we'll just call them x right now, then that point right here is on the angle bisector. That makes this angle the same as that angle. Okay. Opposite of that is if I have an angle and I have an angle bisector, which makes this that, and then I come in and I take any point off of the angle bisector, then that means it's the same distance from the sides of the angle. Basically, what you're saying is any point on an angle bisector is equally distanced from the sides. So you can go knowing the distance and say, okay, this is a bisector, or you can know that it's a bisector and know that the distances are equal. Not too bad? All right. Again, same with the segment. If I have a segment and I have some point, and this distance here is the same as this distance here, which in my picture it's not, but we'll pretend that it is, then I can draw a line through there and it lies on the perpendicular bisector. And that point could be anywhere on this line, including right here. It can be on the actual segment itself, or it can be anywhere out in space. Or we can go backwards, and if I have a segment and I have a perpendicular bisector, so I know that those two lengths are the same, then any point on there is going to be the same distance from the ends. Not too bad? Altitude right here means 90 degrees. Okay? That means that this angle is actually a 90-degree angle. So 3x minus 15 is 90. Add 15 to both sides. 3x is 105. Divide by 3. And x is a lovely 35. I have an angle bisector. Because this is an angle bisector, that tells me that this length is the same as this length. since the lengths are the same. 3x minus 5 will equal 2x plus 17. And then you'll solve it from there. I'll take 2x from both sides. And then I'll add 5 to both sides. I'm just saving room. To get that x is equal to 22.
I almost killed someone, but
Again, since they're both 90, rather than solving them separately, they both equal 90, so they equal each other. Subtract x, add 6, to get 2x equals 20, so x equals 10. Here I have a perpendicular bisector, which tells me that these two are equal to each other. You guys are noticing the equal to each other pattern really strongly, I hope. Subtract 1. 2x equals 22, so x is 11. And finally, angle bisector, which tells me these are the same. So 6x minus 15 is equal to 3x plus 30. Subtracting 3x gives me 3x. Adding 15 gives me 45. So x is 15. Bisecting means cuts in half, which means equal. Yeah, pretty much. The bisecting is cutting in half. Now, the time that it would matter if this said AB is a perpendicular bisector and you didn't have these numbers here, but maybe you had like 3y plus 6. I said y and I put an x. 3y plus 6. And you need to solve for y because it's a perpendicular bisector. That makes it 90 degrees. So then you would come in and say, okay, 3y plus 6 equals 90. And then solve it from there. And then altitude, if you have two angles on your altitude, like this, they're both 90, so they're equal to each other. If you have one angle, it just equals to 90. So on these, you're pretty much only going to have two situations. Equals 90, equals each other. Not too bad? Here, you guys try this one.